What is electric dipole? No idea. Divya, what's the electric dipole? Divya, can you hear me? Can you or can you not?
Separation of positive and negative charges, sir.
Yeah. So it can be like a dipole. If I have both positive, will it be dipole? Or if I have both negative, will it be dipole? Yes or no? Will that be a dipole if I have both positive charges and both negative charges? Will that be behave as a dipole? Yes or no? Varsha?
Yes, sir.
Like if I have both positive charges, will that behave as a dipole? Yes, no, no idea. What happened? You become blank. Okay. See, what?
No, sir.
Sorry, yeah. Yes, Divya.
I think it's no, sir.
No.
Yes, sir.
Okay. Uh, if possible, can you clarify? Why no? No idea. Okay.
It consists of opposite.
Exactly. Opposite charges, but not just opposite. Yes.
Equal and opposite.
Exactly. It should be equal and opposite charges. That makes a dipole moment. That makes a dipole. Okay. Let's come back to Gauss law. It states that net flux through a surface in a vacuum is equals to 1 by epsilon naught times net charge within the surface. Very good. Dog started. Let's go with application. First application. Determine field due to point charge. Determine electric field due to point charge. radius r, center O. At center there is a charge q, a small surface. From that we are passing electric field, that is dA. So q is a point charge at center of spherical surface. Excuse me, I'm sorry. Now this E and dA. Gaussian surface, this surface, and electric field E parallel to dA, as shown here. See here, that was shown here. If I take this one here, same thing. If I take this one here, same thing. Same thing. Point on now. What do you mean by Gaussian surface? Can someone tell me? Come on. What surface we will say that this is the Gaussian surface? Yes?
The surface that we choose for the application of Gauss law.
Yes, exactly. Which follows the Gauss law. In short, it requires a closed surface. If I write in short terms, Gaussian surface, like we required what? Closed surface. Where flux will pass through it, in short. Okay. So let's write formula for this one. Okay. Integration E dA, which is A equals to 4 pi r square epsilon naught equals to, in A also will be 4. Oh, you forgot Q. Sorry. Q 4 pi Q 4 pi epsilon naught R square. So what is this phi value? And this was a phi value. So we are equating Q by epsilon naught E dA. So dA will come down. So we are getting here this value. Can you all hear me right? Am I audible or shall I speak a little bit louder?
Audible, sir.
Super. Second, electric field due to cylindrically symmetry charge distribution. Okay, suppose let's take a shape. Okay. It's a cylinder. Let's take a surface as usual. Let me change color. Electric field dA. On this electric field here, dA here. This is the Gaussian surface. length L. Okay. We have taken one small surface. With that, we'll calculate. So just let's consider a few things. I'm not writing in like detailed. We can consider that. Let consider this, that R is the radius, R is the distance, whatever it is. Okay. We can continue with that. R is the distance from positive line here, which we have drawn. Those are infinite. Fine. So lambda is charge per unit length. Which is constant. And as this is a Gaussian surface or cylinder, so flux through Gaussian cylinder is 0. So now let's talk about electric field. It is perpendicular to dA. See, we have drawn here at bottom. And then sides, it is parallel or the same side. So phi equals to integration of E dA we need to add for those circles or cylinders as well as sides. Both things we need to add. So flux through both ends plus flux through cylindrical surface so as we wrote above, so both surface is 0 plus E area is 2A two sides equals to area will be pi r into that length. Q inside by epsilon naught equals to lambda L by epsilon naught E equals to lambda 2 pi epsilon naught R. Okay. You understood this derivation? What we did here?
Yes, sir.
Any point that you are confused? Like how we got this, how we are getting this? No? If you are having doubts still, okay, let me write some points so that we can remember. Let's conclude these points. First one, what we wrote? Closed imaginary surface drawn around a charge. Are called Gaussian surface. These are like points to remember, so that you won't get confused. Let's make all the points. If flux emerging out of Gaussian surface is 0, then it is not necessary that the intensity of electric field is 0. See, flux is 0, it's not necessary that electric field will be 0. It's never necessary. Now, what is E here? What is E? Yes, quickly tell me, what is E? What is E? What is dA? What is Q? What is epsilon naught? Yes, Divya? What is E? Divya? Not there? Varsha?
Electric field,
Yeah.
sir.
Electric field and dA? Varsha, what is dA? Are you there, Varsha? Or not there?
So could you repeat? Your voice is lagging.
My voice is lagging. Okay. Sorry. So what is dA?
Yes, sir.
What is dA? dA? You guys can't hear me? Is it lagging?
It's lagging, sir.
Oh God. Now check, is it okay now? Can you hear me properly?
So it's still lagging.
No, sir, still it's lagging.
Yeah. I guess now somewhat.
So your voice is not audible properly.
Okay, I'll just write here points to remember. Due to all charges lying inside or outside surface is equals to flux due to the charges enclosed by the net flux of electric field through closed surface due to all charges lying inside or outside the surface is equals to flux due to charges only enclosed by surface. Was it audible now? Was that audible now?
Still lagging, sir.
Oh gosh. Does not depend upon dimension. Enclosed by the surface. Have you written? Have you written? Done writing? I guess so now it's clear, right? Now change network. Have you done writing? Divya, Varsha?
Yes, sir. In which of following figure electric flux is maximum? Let me draw some surface. A. B. C. Which one? Answer this. Jafar. What do you think, Divya? What do you think of this? A, B.
B. Okay. Varsha? Varsha, what do you think? A, B, or C? Divya, till then you can go through the points which we wrote just now. I'll ask you again.
Yes, sir.
Varsha?
Yes, sir.
What do you think? Which one, A, B, or C?
So A.
A. It's odd surface, that's why. Okay. Again, Varsha, I'll ask you again. Go through the points which we wrote, 3, 4 points, 4, 5, something points we wrote. How many points we wrote? 5. Yeah. Yes, Divya. Tell me now. Did you read the all 4, 5 points?
Yes, sir.
Okay. What do you think now? You want to change answer or same answer? Varsha, till then you can read those 5 points. I will ask you again. Come on, guys. Start thinking. You're preparing for JEE exams. So you start thinking, okay, why, what, when, how.
It is 3 of them are, sir.
I'm sorry? It is? It is what? You said something?
B and C, I guess, sir.
Yes.
Because
Because? Go on. Yes, yes, go on.
both are closed objects.
Okay, okay. See, here there are 3 objects. Don't take distance between those 2 objects, okay? We are saying object option number A, option number B, option number C. Just now we wrote 1 point. Okay, let me ask one more time to Varsha. Varsha, do you want to change your answer? Varsha,
Yes, sir. C.
C.
Yes, sir.
She is saying C and Divya is saying B and C. And what about Jafar? Do you want to share your answer? You can share in chat box also. No? He doesn't like to share answers. Okay. Electric flux does not depend on dimension, but depends only on net charge enclosed by the surface. What does it mean? Surface. Clear? Divya, Varsha?
Yes, sir.
Varsha?
Yes, sir.
ठीक है,
Yes, sir.
ठीक है, okay. So it does not depend on shape or size. But if we have Q here and 2Q here and 3Q here, then we can say C is the maximum. It depends upon total net charge. density of 1/3 centimeter by -1. Then find the magnitude of electric intensity at a point away. Okay. Infinite long thin straight wire has uniform linear charge density of 1/3. This is 3, okay? One-third of centimeter inverse. Then find the magnitude of electric intensity at the point 18 centimeter away. ठीक है. This is distance r. Let's assume. And this is distance L. So given lambda equals to 1/3 centimeter inverse. So EDS equals to Q by epsilon naught. As usual, pi r square will pi r will come here, pi r L. Same thing we are doing, nothing big here. Now Q equals to lambda by L. Unit charge per length. 2 pi r epsilon naught L. So we have everything. This is lambda into 2 by 2 into pi into epsilon naught. Oh, I got disconnected. Can you hear me now?
Yes, sir.
this will be give you 4. 4 1 by 4 pi epsilon naught will give you 9 into 10 to power 9 into 1 by 3 into 2 into 18 centimeter
So your
square.
screen is not visible.
My screen is not visible, guys.
No, sir.
It is not sharing, sir.
I shared.
We are unable to see it, sir.
Now okay. Oh, I have unstable internet. Now, can you see my screen?
It's loading, sir. We can see now, sir.
Okay. So 1 by 4 pi epsilon naught will give you 9 into 10 to the power 9. That is 1/3 of this one. And 18 into 10 to the power minus 2 is given in your question. Away from 18 centimeter. So if you multiply 3, 3, 18, 9 2s are 2, 2 will get cancelled. 1 by 3, 1 divided by 3 is 0.33. Okay. 0.33 into 10 to the power 11 Newton per coulomb. Okay. Can you see my screen, right?
Yes, sir. Yes, sir.
Okay. You done writing? Or you need to, shall I scroll up or somewhere?
So your voice is lagging.
Done writing?
Yes, sir.
My audible or something? Okay. Shall I stop sharing?
Yes, sir.
Okay. Okay, guys.